Hello everyone, hope you're doing good and welcome back to my channel. Today we are at the day 6 of the June Daily Code Challenge, and we again have a easy question in front of us. And to give you a brief overview of what was until now in the June Daily Code Challenge. Till if you see the yesterday's question, it was also a out of sequence question, and it was also on the easier side. But prior to that, we mostly had questions on BFS and DFS till June 4, if I am not wrong. And yeah, that's all about it. We are having graphs and tree related questions, right? But from the last 2 or 3 days, we are having a bit different set of questions. And this is the second easy question in the June Daily Code Challenge. So, coming to today's question, question number 1502, can make arithmetic progression from sequence. So it's on the easier side. It's like very simple kind of question. You just have to understand one point here. Once you get that point, it will be very easy for you, right? So they have given you can see there only one input, which is a list or array, whichever you call it. Sequence of numbers is called an arithmetic progression. So basically, this concept revolves around arithmetic progression. In short, we call it AP. You might have learned this in your junior classes. Most probably in 9th or 10th if you are from CBSE background, right? So what we are asking is, see, they have first of all defined what a arithmetic progression is. It's a sequence of arithmetic progression if the difference between any two consecutive elements is the same. Okay, that for example, see in this case, this is a arithmetic progression. Why? See, 3 minus 1 is 2, right? Similarly, 5 minus 3 is also 2. So you can see that this is the definition. If the difference between any two consecutive elements is the same, then it is arithmetic progression, right? So now, what is the question? Given an array of numbers ARR, okay, I will call it array. Okay, ARR array, which we call it. Return true if the array can be rearranged. It can be rearranged to form an arithmetic progression. Otherwise, return false. That means the given array we need to rearrange, and only then we will get it. Okay. Uh, Now, see, there are many ways to do it. Let me be very frank to you. There are many ways to do it, but the most easiest way will be because see, if you see the final order, okay, see the arithmetic. See, for example, see they are talking about difference here, right? The difference can be positive, it can be negative. Okay, but remember, once we get a positive difference, that should be continue for every two consecutive elements. Okay, so it's upon us which way we want. Okay, for example, if the same thing are reverse, okay, for example, 531, you'll get to know that the difference coming is negative, that is -2. Okay, so by now you would have understood that either it could be positive or it could be negative. But once it is positive, it has to be positive for all the consecutive numbers. Okay, so now they are saying the difference. Okay, that means for any ai minus a of I minus 1, it should be positive, either positive or negative. Okay, so let us take the case of positive first. Suppose ai minus 1 is positive. What it concludes? It means ai is always greater than ai minus 1. Okay, that clearly means it's a sorted array. Okay, please pay attention to what I'm saying. Ai minus its previous element, that is any ith element minus its previous element, should be always positive. What it indicates? That indicates the ith element is greater than its previous element, right? That is the basic idea, which indicates the array is sorted. Okay, so that leads us to the solution. The idea is we'll sort this array. After sorting it, we will try to see that the difference of every two consecutive numbers, if they are the same, then it is an arithmetic progression. If they are not the same, if any between any two consecutive numbers, if the difference is not matching the previous differences, then we will return false there and there. Okay. See, we just require one pair to not match the difference. Okay, once we get the one pair, we can simply return false. We need not check the rest of the pair. That is basic idea. So this is going to be the solution. It's a really easy question, but you just need to analyze this point. Okay, that arithmetic progression basically indicates that either the array is sorted or see, sorted never means that only in the ascending order. It could be in the descending order also. If you consider descending order, we will always have this difference between two consecutive terms as -1. This is an example of that. Okay. So for current question, I am sorting it based on the ascending order. Okay. So first, I have taken the n. Okay, n is the length of the given input to us. We'll sort the input given to us. We'll find the difference of the first two elements. Okay, that is the index 1 and index 0. Then we will start from the second index onwards till the last element. What we'll do is from the second index onwards, we'll try to find the difference of the current element and its previous element. We will try to check if it is equal or not equal to the this is difference. What is the difference? It's coming from here. If any of the things are not matching to this, we'll return false then and there. Okay, remember the program will end then and there. Okay, we will not check further. But in case this for loop ends without this condition getting true, in that case finally we return true. Okay, the true will be returned only if all possible consecutive pairs are having this particular difference between them. Okay, so that is the basic idea, friends. Um, See, if you talk about the time complexity, obviously it's going to be O of n. Sorry, not O of n, because see, we are using sort. See, this particular thing is O of n, you can see. But remember, we are using a sort, okay? So whenever we use a sort, time complexity basically bulges to O of n log n, okay? If you talk about space complexity, there are two ways to do it. See, space complexity, if you want to include the internal space consumed, because see, for sorting, some space will be consumed. Okay, if you are trying to consider that, then it will be again in the range of n log n. But if you are not considering that, then it will be over one. Okay, it's almost going to be over one because we are not, creating any array of our own. Okay, or any element of our own. That is the basic idea, friends. But see, it all see when you have interview in front of you, you just need to analyze what they want. Okay, if they want you to consider those things, then you should consider. For example, if there is sorting involved and they are trying to ask you the space complexity, just mention to them whether I need to consider the space complexity, that is the extra space which is being involved when we are sorting in the array. Okay, through the internal method. If they say yes, then consider it. Just take n log n, and if there is anything more than that, take the max of that. If there is nothing involved, if they don't want to consider all those things, then simply take for the rest of the thing. If you could talk about this code, then the space complexity will be O of one. Okay, so that is the basic idea. And yeah, if you have any further easier way or better way of doing it, please do let me know. We can discuss it further. That's all for today. See you all tomorrow. Thanks a lot.